academic channel segment. Here, I will be taking your children in Basic 6 for mathematics entrance exam. I am Akilapa Oluwaseun. Here, we make mathematics as simple as A and B and C. Thank you. Now, this is our first question. Question number 1. Here it reads, a mass property worth 64,800 naira. He gave his eldest son 28% of his estate. His second and third son were given 27% respectively, while the remainder was given to his younger daughter. How much was given to the youngest daughter? What can we do in solving this kind of situation? Number 1, take note of the monetary value, the money given the man has, which means the worth property of the man, and that is 64,800 naira. And here the man gave his eldest son 28% of the monetary value. Likewise, he also gave the other two sons 27, the second one 27%, the third one 25%. Now, the daughter. The question now says, how much was given to the youngest daughter? What can we do to get the amount given to the younger daughter? To do this, what we just need to do is that first you are to take note of the percentage. Percentage means equal to, the total percentage is equal to 100. What we have to do is we have to identify the percentage given to the youngest daughter. And how can we do that? First, we have to have the percentages in this question together. After adding them together, the next thing, we remove the total percentage from the 100%. And after which, that will give us the percentage of the daughter. Then, after you have gotten the percentage of the daughter, you can now use that percentage of the daughter to multiply the worth value of the man. So this is how it goes. Solution. Our first step is 1. Plus all the percentage together. Total the percentage, which is 28% plus 27%. I hope you are watching. 27%, the third percentage, which is plus 25%. And what will this give us? To calculate this, we have to make it as simple as ABC. Don't forget, which means we say 28, let's arrange them together, 27, then 25. Don't forget, all beside it, percentage. Then we add them together. So this is just the arrangement. Now let's go. 8 plus 7 will give you 15. Then plus 5, that will be 20. Now don't forget, you have to write your 0 here and carry, which means carry the number under the tens to the 10 side. Now you have this and this and this together also. Let's go. 2 plus 2, which is 4. 4 plus 2, that will be 6. 6 plus 2, that is 8. You have 8. Now, altogether, you have 80. Now, that is 80%. Now, after you have gotten the 80%, the next thing, don't forget that our total, like I said before, the total percentage is 100%. And here we have 80% after adding all the percentage of the 3 sums together. Now, can you tell me how many percentage remaining? That's great. Which means 20% remaining. How do I get the 20% remaining? This is how you do it. Remove the 80% from the 100%. which is the total percent. Now, the next step, this will now lead us to our next step, which is now our total percentage, which is 100% minus 80%. And that gives us 20%. Now, if you add your 20%, which means the 20% remaining belongs to the youngest daughter. Now, which means that what? The youngest daughter percentage is 20%. Now, this is just the percentage of the youngest daughter. The next thing we are going to find now is, coming back to the question, how much was given to the youngest daughter? How much is different from what is the percentage? Except if they ask you in the question, what is the percentage? That is when your final answer will be this. Then you go through the option and pick your answer. But here they said, how much, which means they are talking about the monetary value. For you to get the monetary value, how much was given to the daughter, you have to use this percentage to work on the monetary value. Now, that will lead us to the calculation of the monetary value. As I was saying, which means the next thing we have to do now is to make use of this 20% to work on the value given to us in the question. Now, we have the what value of the man, the what value of the man, which was 64,000 naira. 64,800 naira. Now, the value of the percentage of the daughter, the youngest daughter percentage, which is the youngest daughter percentage of the youngest daughter, which is, tell me, great, which is 20%. Now, the next thing we are going to do now is we are going to multiply this percentage by this. Now, let's see. And that's going to be 20% times 64,800 naira. Now, what then can we do? What then are we expected to do? Don't forget, when you have something like this in mathematics, percentage, you have to take it to fraction. What will be the fraction of 20%? Good of you, which is 20% in percentage is the same thing as saying 20 all over 100. And that is the fraction. Now, so we are going to change this now to fraction, which is this. Which is now 20 all over 100 times 64,800 naira. Don't forget your naira value. Now, the next thing, this is where most children find it somehow difficult. But mind you, we are dealing with mathematics, making mathematics as simple as A and B and C. When you get to this point, you don't need to find it difficult at all. What will you do? Just remember the technique of your common factors. If we check this, what is the common factor? You ask yourself, by the time you get to this point, just ask yourself, can I have a common factor between 20 and 100? If you can, then the number you thought of is the right number. Now, which means, here, my common factor between 20 and 100, 20 is 20. which means I can have 20. 20 can go in 20. Likewise, it can also go in 100. There's also another common factor. If you don't want to go through this means, you can also go like this, which is this and this. Now, and that will be making use of common factor between this number and this number. If you are using the common factor between this number and this number, then you are going to think well. For example, this is 100. Can I count in 100? That will give me 64,800. These are questions you need to ask yourself. Now, so I am going through this means first, then that means I'm going to say 20 times what will give me 20. 20 times 1 will give me 20, which means I have my 20 back. Likewise, 20 times what will give me 100, and that will be 20 times 5, correct, which means I'm going to have my 100. Now, you will see that the common factor in this multiplication and this multiplication and this multiplication is 20. So the common factor there is 20. Now I'm going to use this 20 to divide this and this now. So that leads us to the next step. And that's going to be 20 divided by 20. Because 20 can go in 20 now, based on what we've done here. So 100, this 100, divide it also by the common factor, which is 20. Then times, don't forget this is still there, 64,800. Now, can you tell me now, 20 divided by 20 is 1, correct? Which is 1. Don't forget, you can come back to the multiplication we have just done earlier, which is the number that times this 20 that gave us this 20. Likewise, the number that times this 20 that gave us the 100. And that will give us this. So which means 20 in 20 is 1. 20 in 100 is 5. Now, why this? You cancel this and this. You don't need them anymore. Now, you move down to the next step. Which is this. The next step now. Here you now have 1 left at the top, all over 5 left at the down. Times, why this? Don't forget. 64,800. Now, the next thing now, like I said, you also look for the common factor. Don't forget, when you have fraction, multiplication in fraction, it must be what? You must always make use of your common factor. Always look for the common factor when you have multiplication of fraction. Now, checking this out, you have this. This is like a large number, very big number. Yes, very big number. But mind you, you can make it easier. How can I divide this number without what? Without any difficulties. Now, mind you, 5 can go in any number that has 0 as a unit number. 0 at the unit. 0 at the unit. Which means 5 can go in 64,800. Likewise, 5 can divide 5. Now, I am going to now say 1 all over 5 times this number, divide both by 5, and divide this also by 5. Now, so this will now lead us to 5 in 5 will be 1, which means 5 times 1 will give us 5. And don't forget what I did up here, similar thing we did up here. Now, likewise, we are going to also say something about this. But how can we now divide this number? What we will do, we will start from the highest value. Whenever you are dividing, you must always start from the highest value. And that's going to be, you ask yourself, 5 in 6. How many 5 can we see in 6? Great. It is 1. Remainder 1. Which means 1. Add 1 to this. That remainder 1, add it to this. Now, you ask yourself again, 5 in 14. Slant it, 5 in 14. 5 times 1 will be closer to 14. Correct. And that will be 5 times 2. 5 times 2 is 10. 5 times 3 is 15, which gives you more than 14 here. Now, you are going to go back to 2, which means 5 in 14 is 2. It will remainder what? It will remainder 4. You will add the 4 to this. The remainder, you join it to this 8. Then you ask yourself again, 5 in 48. 5 times 1 will give you answer closer to 48. Great. 5 times 9, which is 45. Correct. You slant this off again, you write 9. It remainder what? 5 times 9, which is 45. It remainder 4, which means it remains 4 to reach 48. Then that remainder 4 again, add it here to the 0. Then you have 40. Now, 5 in 40, can you tell me 5 times what will give you 40? Great, and that is 8. 5 times 8, which is 40. You write the 8 up. You will discover that there's no remainder here. There is no remainder in this calculation here. But we still have another last number. Now, 5 in 0, or we say 0 divided by 5. Any number that is dividing 0, the answer will be 0, will be equal to 0, which means 0 divided by 5 is 0. You are going to write the 0 up. Now, check them out. Check them out. Now, don't forget, slant this and slant this. You don't need them anymore. Now, what you have here now is what? Don't forget your NERA. Your NERA must come up. Now, the number of that you have just calculated will be 12,980. So, which means this is our final answer. How do we get the final answer? This one times this. Don't forget, 1 times 1 is an identical number. 1 times any number will give you the number you used to times the 1. So, which means it gives you back. As you throw it to it, it comes back to itself. So that's it. So this is your answer. So you go down to your option, check your option from A to E. If this answer is there, then you shade. That is your answer. These are the steps. An equilateral triangle has dash sides. An equilateral triangle has dash side. This is talking about shapes. Yes. This is another question. Question number 3. If you are given this kind of question in your exam, and they say, which of the following are the prime factors of 90? Don't be confused. What they meant is this. They meant which of the numbers which of the numbers that can divide 90 that are prime? Which of the numbers that are prime that can divide 90? Don't forget, prime numbers, you must understand what your prime numbers are. Prime numbers, they are numbers that has just 2 factors, that have 2 factors. And what are the 2 factors? The 2 factors, they are, for example, what are the prime numbers of 3? 3, what we meant there is that what can divide 3 without a remainder? What can divide 3 without a remainder? Now, for example, can you think about the number that can divide 3 without a remainder? Now, okay, such as 1. 1 can divide 3 without a remainder. 2 cannot divide 3, it will surely remainder 1. For example, there is nothing that will times 2 that will give us 3. Or do we have? Correct. No, we don't have. For example, 2 times 0 gives you 0. 2 times 1 is 2. 2 times 3 is 6. And that is more than 3. So which means in the set of multiplication of 2's, there is no 3. Now, the next number will be 3, which means these are the 2 numbers that can divide 3 without remainder. So this 1 and 3, they are said to be prime numbers of 3, and they are also said to be prime factors of 3. They are prime numbers. This 3 is a prime number, but this 1 is not a prime number. But mind you, this 1 is said to be a factor of 3, which means 1 can divide 3, but it's not a prime number. Don't forget, a prime number must what? Must have just 2 factors. All these two numbers, they are two factors of this prime. So this is a prime number. So 3 is a prime number. Now let's come down to this now. From what I have just explained there, we are going to apply this now. Now, 90. How can we do this? Just write your 90 down whenever you are asked to find the prime factors. Now, you have to remember those prime numbers. What are the prime numbers? I'm going to write the prime numbers here. From the smallest, the starting point of the prime numbers start from 2. Mind you, prime numbers. Prime numbers. Prime numbers are starting from 2. They don't start from 1 because 1 does not have 2 factors. Don't forget what I said before based on prime numbers. I said prime numbers are those numbers that have 2 factors, which means the 2 factors are 1 and the number itself, which means these are the 2 numbers that can go in that number. For example, 2 has 2 factors, which means 1 can divide 2 without any remainder. Likewise, 2 can divide 2 without any remainder. No other number after 2 follows 3. 3 also is a prime number, which means 1 can divide 3, like we've done here. 1 and 3 can only divide 3 without any remainder. Is 4 a prime number? No. Correct. So 4 is not a prime number because it has more than 2 factors. Now, 5. Yes, 5 is a prime number. Now, let's stop here. Let's come back to this question. But take note, we are still going to make use of this number in this calculation. Now, let's see. Here now we have the prime factors of 90. The prime factors, which means what you are using must be prime numbers, which means it must be prime numbers that you must apply to divide, to calculate something of 90. Let's go now. How can we do that? Just construct a line like this. Now, let's start. Tell me, what is the smallest prime number? Great, and that's 2. This is the 2. The smallest prime number is 2. Now, you are going to use, can 2 go in 90? You ask yourself. Now, look at, another technique you should note is that 2 can divide, can go in any number that has unit 0, which means 0 is at the unit, like you are having 0 here. Likewise, 5 can go in any number that has unit 0. So you should take note of that. But we are starting with 2 because 2 is the smallest prime number. You will start, you check up with 2. Let's check up now. Let's check up our working. Before I will write 2 here, let's check it out here, which means I'm going to say 90 divided by 2. You can do that also in your jotter. Now, 90 divided by 2, starting from here, that will be 2 in 90, 2 in 9 will be what? Check your multiplication table. That will be 2 times what will be closer to 8? That will be 2 times 4, which is 8. Now, if you increase this 4 to 5, it will give you 10, and it has passed 9. So, you will cancel this. You don't need this. You will come back to this. That gives you the number closer to 9. Now, after which means 9 divided by 2 is 4. You write this 4. You use to times the 2 here. Now, that will be 4. Then you come down to this. It remainder what? Find the Rn. The Rn will be what? to calculate the RM, that's going to be, remove this answer you got here from this 9. That will be 9 minus 8. That will be 1. Now, you have the 1. That's how to calculate your RM. RM means remainder. So, that's 1. Then that 1 now, I'm bringing it here to the back of the 0. Now, this will now be, you also ask yourself, 2 in 10, that will be, you can now see where you cancel before. 2 times 5 gives you 10, which means 2 in 10 is 5. That gives you this 10 that you have here now. So that's going to be 5. Then, what you now have is what? Do you have any other number at the front of this 0? No. So you have 45, which means 2 can divide 90 without any remainder. Then I'm going to bring the 2 here. Then bring back my arrow. Then the answer, this back arrow now is bringing back what the result was in our calculation here. What the result was, which was 45. So I'm going to drop the 45 now, and that is what you are expected to do. Now, here we still have 45. You are still going to proceed. Look at 45, which means you are still going to make use of the prime number you are still going to think of a prime number that can go in 45. So what is that prime number? It's a question you need to ask yourself. What is that prime number? Now, you check your unit size, the unit size of the number again. This unit size is containing 5. Any figure that has 5 at the unit, which means prime number 5 can divide such number. Prime number 5 can divide such number. Now, you can now make use of 5. I'm using this 5. Mind you, if you don't want to use 5, you can also try 3, because after 2 is 3. You can also check up on 3. I think 3 can also go in 45. You are thinking what I'm thinking. That's great. Now, so let's see. Which means, but I am using 5 now. This doesn't stop you from using the 3 if you want to. Now, so here now, you are going to ask yourself, 5 times what will give you 45? Can you tell me? Great. Now, that will be 5 times what will give you 45, and that is 9, which is 5 times 9 is 45. So, tell me, what is that number that times 5 that gives us 45? It's 9, correct. So, the answer you got here, you put it down also. Are we there? Are you following? Okay, now, which means you have 9. Check your 9. This has not reached final bus stop until it gets to 1, because 1 is not a prime number. Take note. 1 is not a prime number. I repeat again. 1 is not a prime number. Now, but 1 is a factor. Now, mind you, you have 9. Now, if you check up your 9, what is the prime number that can go in 9? Good, which is 3. Which is 3. And that is the 3 here, like I've said before. Now, so I'm going to come back to my arrow point, then bring it, slant it down again, then put my 3, which is the prime number I'm going to use. Now, so which means I'm going to come down here by saying this 3 times what will give me 9. 3 times, correct. 3 times 3 will give us 9. So which means that 9 divided by 3 is 3. The number that times this 3 to give us 9. So that means you are going to drop this 3. Now, let me ask you, has this 3, this number, has it reached 1? No, it has not reached 1. So far it has not reached 1, we are still going to proceed. We are still going to carry on with the calculation. Now, tell me, what is the prime number that can go in 3? Good of you, and that is 3. Which means 3 can divide 3 without any remainder. Now you still have to write the 3 again. This one has been used, so don't use this one again. Use another one. So that will be 3 divided by 3, and that will be 3 times 1, which is 3. Which means the number that will times this 3 to give us this 3 is 1. So which means 3 divided by 3 is 1. So finally, we got to the 1 point figure, 1. So the 1. Now, what next are we then going to do? Coming back to the question, they said, which of the following are the prime factors of 90? Which of the following are the prime factors of 90? Now, what next? You have just used the prime. All these numbers now, they are prime numbers. They are prime numbers. Don't forget what I said. I said prime numbers are those numbers that have 2 factors. They have 2 factors, and the 2 factors are 1 and the number itself, which means 1 and 2 can divide 2. 1 and 5 can divide 5 without any remainder. 3 and 1 can divide 3 without any remainder. So now, our next step is that we are going to write out all the prime factors. And how are we going to write them out? We are going to write them this way. Don't forget, the way you have done it, you are going to write them first. 2 times 5 times 3 times 3. But check, the next thing you have to observe is that these prime factors are not properly arranged. Are they properly arranged? No, correct. Now, so far they are not properly arranged, what we are going to do is to arrange them properly. It means that what? That what we have here, you are going to rearrange them. Which means according to order of arrangement. 2 is the smallest, followed by 3, followed by 5. Then I'm going to put them that way. 2 times 3, followed by another 3, followed by 5. They are still the same. They are still the same way. If you multiply them here and you multiply this here, you will still have the same answer. And what will your answer be? Your answer will be 90. So let's check. To check if you are correct or wrong. 2 times 5, correct, 10. 10 times 3, correct, 30. 30 times 3, correct, 90. Now, the same way you will get this answer back. So, which means you are absolutely correct. Mind you, if you are dividing in this kind of question and they ask you, which of the following are the prime factors of 90? If you make use of any number that is not prime factor, you must make sure that you break them down. If you do not break them down to the prime factor, then you will fail it. Now you can easily go back to your question options, then you sort out where this kind of statement is being made. Mind you, in some questions, we can also take it to what? To standard form. They can leave the question in standard, or let's say in index form. Index form. So what then will be the index form of this number? Index form is like raised to power, which means when a particular number occurs more than 2 times, it's going to be raised to power 2. And that's going to be this one. How many times does it occur? Once. You just write 1, 2 times. Why 3 occurs how many times? Correct. 3 occurs 2 times. Then just write 3. Then the 2 times it occurs, you just put a small 2 at the top of the 3. And that is said to be 3 raised to power 2. Then lastly, times 5. So because 5 occurs once, this is your final answer. This may be your answer, or this may be. So that is that. This is another question. Question number 4. A driver was paid 18,000 naira for 10 days. How much will he receive for 15 days? How much will he receive for 15 days? Now, you could imagine you are being paid 18,000 naira for just 10 days. And now, for 15 days, you want to calculate how much your money will be for 15 days. How can you do this? It's as simple as ABC. Now, what will you do? First, one thing you need to do first, you need to know how much you are being paid for 1 day. For 1 day. If you know how much you are being paid for 1 day, that makes your money to become 18,000 naira in 10 days. Then it will be easier for you to calculate your 15 days, amount you are going to get for 15 days. And how can you know how much you will be paid? You are being paid for 1 day. What you will do is that divide the money for 10 days, the money given to you for 10 days by 10, which means by the 10 days. Then the answer you get, use it to multiply the 15 days. Then that will be your answer. Now, this is the solving. Which means we are going to say 18,000 naira divided by 10 days. Mind you, if you don't want to say divide, you can also use the word fraction, which means fraction all over. So I'm going to apply fractional technique here. So fractional technique is going to be all over 10. Are you following? Okay, so which means I am applying the fractional technique instead of saying 18,000 naira divided by 10. So I can easily say this. Now, so then after which you can now times it by 15 days that you have, which means you divide this, then the answer you times it by 15 days. So that's simple. Now, let's see. What next? Don't forget the technique I gave you before. Just say, how many 10 can you common factor between these? Don't forget what I said before in question number 1. I said, when you have times in between fractions, multiplication in between fractions, this is a fractional number now, then there's times here. So what you do is I find the common factors. Mind you, 10 can go in 10 here. Likewise, 10 can go here. Why? Because there is 0 at the unit side. So, in as much there is 0 at the unit side, likewise, 10 can divide such kind of number. So, our next step now will be 18,000 divided by the common factor all over 10 divided by 10, which is the common factor. These are the common factors. Times, you will still have to leave this alone beside it. Now, the next thing now, come here, look at this. How many 10 can you see in 18? In 1, impossible. What you do, put 0, join the 1 to this again, because it's impossible. 10 times 1 will give us 1, nothing. So, 10 times nothing will give us 1, so it's impossible. So, this one now, you shift it to this 8, that becomes 18. Now, 10 in 18, that will give you 1. Why? 10 times 1 is 10. 10 times 2 is 20. This has passed this 18. Now, you don't need this for now. Now, you come back to this. Now, that means 10 in 18 will now be 1. Remember what? If you check, look at the result is 10, which means, what does this 10 remain to reach 18? It remains 8. Great, good. Now, it remains 8. Now, which means the remainder there, the Rm is 8. Now, Rm, which is 8, that's 8 now, you bring it to the next side. Now, and that is 80. Now, 10 in 80. Don't touch this ones yet. Just deal with these two. 10 in 80. Now, we are going to continue. 10 times 8 will give us 80. Yes, 10 times 8 will give us 80. Now, which means 10 in 80, which is 8, which is this 8. Now, you will observe that there's no remainder here, no Rm. So, you come down to this one, 10 in 0. Don't forget what I told you. That whenever you are dividing 0 by any number, the answer will surely be 0, because 0 is an identity on its own. Now, so which means 10 in 0 is 0. 10 in 0 is 0. So, which means you have this. This one is not needed here because it's at the front, at the back. So, that is 1,800. You have just done that. Now, coming back here, 10 divided by 10, great. That is 1. So, you don't need this one and this anymore. So, you come down now. The next step is this, which is what you have here left is, don't forget your naira, 1,800 naira times, there's nothing here anymore, that's times 15. Now, what are we then going to do? Look at this. 1,800 naira times 15. What will you do? Arrange them. Arrange them. That will be 1,800 times 15. Split them. First start with this unit. You can start any which way, different techniques, but let's start with that technique. This times this, you start with this times this, that will be 0. This times this, that will also be 0. This times this, 40, that will be 0 carry 4. Now, 5 times 1 will give you 5, plus this 4, that will be 9. Then you come down to the second digit. If you are using the second digit to multiply, it must come down to the second digit, which is unit tens, unit tens. So your answer must be written under the second digit. That will be 1 times 0, that will be 0. 1 times 0 again, 0, then you will be going this way. 1 times 8, 8. 1 times 1, 1. Don't make mistakes of saying 1 times 4. This is just the carry of the first one. Then the next thing, you add them together. And that's going to be nothing here. 0 plus 0 is said to be 0. 0 plus 0, 0. 0 plus 0, 0. 9 plus 6, 9 plus 8 will give you 17. Carry 1. Now the 1 plus 1, that will be 2. You have 27,000 naira. Don't forget your naira. Put it down. Now, that's to tell you that what? Good. That the man will collect 27,000 naira. The driver will collect 27,000 naira, no cover, in 15 days. This is the amount, which means the driver received 27,000 naira in 15 days. Full stop. That is your answer. So you go down to your option in your exam booklet and you shade your answer. That is how to solve this question. You can try this on your own, after which you just shut this off, pick the question again, solve it like I have explained, and see if you arrived at the answer. If you are given this kind of question, change 4 plus 6 all over 10 plus 700 to decimal. Change 4 plus 6 tenths plus 700 to decimal. Mind you, you are here changing from fraction. These are fractional numbers, except this. This one is whole number. You are forced to identify that this is whole number, this is fractional number, and now you are told to take them to decimal, which means you want to change from fractional numbers to decimal number. How can you do this? How can you do this? 1. First separate the whole number, then separate the fractional number. That is your first step solution. I am just separating this 4 now, then I also have to separate 6 all over 10 and also 7 all over 10, all over 100 rather. Now, after I have done that, you will see I have separated them. This one here is whole number, this is fraction, this fraction. Now, what will I do? Convert them, turn them to what? To decimal. So far they said, leave your answer in decimal fraction. Now, turn this to decimal. This in decimal means what? Means 0.6. 6 tenths means 0.6. Let me give you one technique. And the technique is this. Put a point, place your pencil, your pen here, move it to the left, once. How many times will you move it? Once. Because, why is it once? It is once because I'm applying this technique, which is the zero. How many zeros do you have there? Just one at the denominator, the base number. That's 1 0. So you move it just once. That movement now is point, is placement of point, which means you have 0.6. Are we there? Yes. Now, can you do something similar here? Look at how many zeros do you have here? 2. You have 2 zeros, which means, tell me, you are going to move your point out. You are going to move your pencil how many times? Good. 2 times, which means move your point 1, 2. Then the last point, you are going to put point. You will discover that here at this point, there's nothing here, which means there's an invisible number there, and that is 0. So this is now going to be 0.07. So that is 0.07. Now, when you have 0.07, take note. Before this point, there is an invisible number also. And what is the invisible number? We are going to make it visible now. And that's going to be 0. Just like what we did here. Here also, make it 0. So, you have 0. So, that now becomes 0.6, 0.07. Now, check this. This one here is what? Is whole number. Is a whole number. Now, this whole number will still come down. You will drop it down the way just to mingle with this. This one still remains the same. Now, what next? Go back to the question. You have sign here in the question. What are the signs? The plus sign. Now, you are going to put the plus sign now. Plus, which means you are going to plus all this together in order to arrive at decimal number. Now, plussing all of them together, that's going to be, you are going to arrange them 4. 4, this your 4, stays up. So, you have your 4, place your 4 there now. Now, arrange this. This 0 here is the side of the whole number. This is whole number point. This 0, the first 0, place it here. The second 0, place it down. Now, come back to this, put your point here and write your 6. Come back to this, put your point here and write 0 and 7. Mind you, this 6 must be above this. Now, 7 beside. Now, then the next thing you are going to do is to plus them together. I hope you saw how I have just arranged the number. This one is whole number. It must stay. Whole number comes before the point. So why decimal number comes after the point. And that is the reason for this arrangement. And you discover that here you have only one decimal number, and why the one here you have 2 decimal number. That's why this 6 must be up here. Why this one must be here where there's nothing. Now you have to add them together now. So the arrangement is very important. If you do not arrange properly, you miss the calculation. Now let's see. Now we start from here, also from the right. That's going to be, so far this place is nothing. Your answer here will be 7. This will be 6, which is 6 plus 0, 6. Then you place your point down. Then this will be 4. Finally, you have 4.67 as your answer. 4.67. 4.67 as your answer. This is your decimal. This is the decimal of this question. Yes, this is another question number 6. If you are given something like this, if you check this properly, you will discover that they are all in fractions. And another thing you should observe is that these fractions are not just ordinary fractions. They are fractions that are taking along with them whole number. There's a straight number beside them. So this 2 all over 3 is a fraction. There's a whole number beside it. This 4 all over 5 is also a fraction. There's a whole number beside it. This also has a whole number beside it. Which means all the fractions here, they have whole numbers. The 3 fractions have whole numbers. Now, another thing you should observe again is that the sign in between them are not the same. They are different signs. You have plus, you have minus. Now, How can you then calculate or deal with this kind of situation? How can you deal with them? Now, what you are expected to do, solution, is one, separate the fractions based on what? Based on the sign beside them, in between them. Based on the sign in between them. For example, separate plus from minus, which means this and this must be separated from this one. So which means first, what do you think you can deal with first? Now, dealing with this first, dealing with the addition first, add the fractions together for you to get the proper calculation. Then after you have solved for the addition, then you can now subtract, you can now remove this from the answer you have gotten or got. Now, let's see, I'm going to separate them now, which is 3 whole number, 2 all over 3, plus 4 whole number, 4 all over 5. Then I'm separating this now, minus 2 whole number, 2 all over 5. Then, after which, I'm dropping this down. What will I do next? I'm dealing with this first. I'm leaving this for a while. Now, I'm dropping this down now. What will I do? Look at the fraction. I'm also going to separate the number beside them. I'm going to separate them, and that's going to be separate the 3 plus 4. Separate them. Separate this also. 2 all over 3 plus 4 all over 5. You can see what I've just done. I've just separated another segment to another segment, which means I've separated the whole number from the fractional number. Now, the next thing, now I'm going to add this together. Now, I'm going to add this together. Let's do that together. 3 plus 4, correct. That's great. That's 7. That shows you are smart. You're a smart kid. You're a smart kid. That's great. Now, the next thing, this one, how can we then calculate this? Mind you, it's as very simple as ABC. But mind you, as simple as it is, like I always say, one can easily miscalculate if you do not calm yourself down. Now, let's see, how can I do this? Look at, these are just 2 fractions I'm dealing with. I'm not dealing with 3 fractions. And mind you, they are what? They are addition. They are both addition. You can make use of different techniques in calculating something like this. You can use what we call the LCM technique. You can apply the multiplication technique. But which one do I want to apply? Let me apply the multiplication technique. Now, what is the multiplication technique all about? The first denominator here, use this 5 to times this up and this down. Use this 3 to times this up and this down. You will discover that something will happen here. Let's see. That will be 2 times 5 all over 3 times 5 plus 4 times 3 all over 5 times 3. What will you see? You will discover that this and this result at the denominator, at the down part of the fraction, they will give you the same result. They will surely give you the same result. Now, and that is what we want to do. We want to make sure that both down numbers, denominators, are the same. Now, let's see. Calculating them down again, this times this will give us 10 all over, this times this, which is 15, plus this times this, which is 12, all over this times this, which is 15. Now, we now have 15, 15. Now, in a very simple thing, the LCM of 15 all over 15, 15 and 15 is 15. Is 15. So you are going to pick one out of this denominator, but the numerator will be written together, and you add them together. So pick one out of these because they are the same. So I'm picking one now. So bringing this down, this is what we are working on now. So that will be 10 plus 12 will give us 22 all over 15. Now, if you check, I now have 22 all over 15. 22 all over 15. You will ask yourself, is there any factor that can go in this? Do we have any factor that can go in this? No. Okay. So far we have no factor that can go in this. What you now do, bring this 7 down to you. Don't forget, this your 7 is this 7 you've calculated here is the whole number. So I'm bringing this 7 down to this now. That will now eventually give us 7 whole number 22 all over 15. Now, don't forget that we have not calculated 1. This is the 1. So, we have not calculated this. Now, you are going to bring this down also. Now, we want to work on this now. Bringing this down with the sign, that will be minus 2 whole number 2 all over 5. Now, just like what we did in the previous, in the addition where we have the whole number 3 and 4, and we separated them from the fractions here, we are also going to separate the whole number and the fraction at the same time. That's going to be 7 minus 2, then 22 all over 15 minus 2 all over 5. Now, this now will be 7 minus 2. Can you tell me? Great. That's 5. That's 5. Now, so you will now have 5. Mind you, we are not going to apply this technique here because the value, the figure we have here is very large. If you check the denominator here, which is 15, the denominator we use here, we have here, is just 5. It's 3 and 5. They are very small numbers. That's why we can apply the multiplication technique here. Using this to times this and this, using this to times this and this, you have 15. But now, the figure here is very big. It's 15. So if I should tell you, you can also apply it, but because, so that you won't waste your time, you need to apply LCM here now. So finding the LCM now, what would then be the LCM of 15 and 5? The LCM of 15 and 5. We are then going to find the LCM of 15 and 5. LCM of 15 and 5. How can we calculate the LCM of 15 and 5? How can we calculate the LCM? Who can tell me? Okay, somebody is talking there. Okay, now let's show it on the board for people to see. Now, 15 and 5, just rule your 2 lines, 2 vertical lines. Why are we reeling 2 lines? We are reeling 2 lines because we have 2 numbers. So, rule another top one on the top. Now, leave this space. This space belongs for the factors, the prime factors, like we did in the prime factors. Now, 15 and write 5 here. Now, check. What is the prime factor? What can go in 15? You must apply your prime factor, like I said. The prime numbers are 2, 3, 5, 7. What again? Can you tell me? Is it 9? No. 9 is not a prime factor. It's not 10. 11 followed by 13. Followed by what? Is it 14? No. 15? No. 16? No. 17? Yes. Blah, blah, blah. Down. So, let's still hold on this. Now, let's check this now. Look at this. What you have, here you have 3. 3 can go in 15 without any remainder. Now, that's going to be, we are going to write 3 here. Now, writing 3 here now, 3 in 15, which is 15 divided by 3, that will be 3 times 5, which gives us 15. Now, which means 3 in 15 is 5. I'm slacking this off. Then, can 3 go in 5 without any remainder? No. So, in LCM, when a prime number cannot go in the number you have at the top, what you have to do is that you will drop down the 5, the number. You will drop down the number like I'm dropping mine. So, you drop it. Now, what next? You ask yourself, is 5 part of your prime numbers? is 5 part of your prime numbers? Yes, 5 is part of the prime numbers you have here, which is this. So 5 is part of the prime numbers we have on the board. Now, so which means here you now have, you are then going to write your 5, which means 5 in 5 will be 1. 5 in 5, this will be 1. So 1, 1 now. So you have 1 now. So until it gets to 1 in LCM, calculating of your LCM. So now, after you have done that, now you are through with that. Now what you now do, you multiply the prime numbers together. 3 times 5. 3 times 5 is what, everybody? Correct. 15. That is 15. Now, you will discover that this 15 is still occurring here in this calculation. So, which means 15 is very important in that scene. Now, which is 15. 15, 15. Now, what are we then going to do? We are then going to do something. Yes, we are going to do something. Are you ready to do something? Are you enjoying it? Oh, that's great. So, now, let's see. 15. The 15 now, what you now have to do is that this LCM you now have here, you will use this LCM, you will divide this LCM by each of the denominators you have down here. So, let us write the fraction up here now, which is 22 all over 5, all over 15 rather, minus 2 all over 5. Then, below it, you are going to rule a very long line, not that long, but just long line. Now, you are going to put this 15 that you got here, which is the LCM, write it down here. Now, after writing down the 15, what you now do is that you will divide this 15 by each of the denominators. Then the answer you get, you use it to times the numerator. And that's going to be this way. This 15, which is 15, divided by this number here, under this fraction. Then put a bracket, times it by the number at the top, which is 22. Then put your minus here, which is this minus. Now, likewise, you open a bracket again, put 15, which is the LCM again, divided by the denominator of this one, close the bracket, then times it by the 2. So that's what we want to do. Now, you can, so that it won't fall off, you know, it won't fall off, make it at the center. Now, so this now, you have this. Now, what you are going to do now is to divide. Let's go. 15 divided by 15, that will give you 1. Now, that is now 1. 1 times 22 will give you what? Which means the answer we have here now is 1. So 1 times 22 minus 15 divided by 5 is 3. And that's 3 times 2. Mind you, you are still going to carry it with this, your 15. Now, that will be 1 times 22 is what? Great. 22. Minus 3 times 2 is 6, correct? All over 15. Now, what do you think we are going to do? Great, good of you. That will be 22 minus 6. You are going to calculate on this, which means that will be 22 minus 6 is what? Are you sure? Are you pretty sure? Great. You are super. You are super. Now that will be 16. 16 all over 15. Mind you, you have 16 all over 15. This 16, take note of it. This 16 is bigger than 15. You could imagine if daddy should sit on you. I don't know the size of your dad. If daddy is very fat, like a fat man, now, if daddy should sit on you, boom, will you be able to carry daddy? No. So let's see. Look at this 16 now is bigger than the 15. So what we'll do, we are going to split them. Let's split them. How many 15 can you see in 16? Great. Which is, we are going to see 15 in 16, 1, but it's going to remainder correct, 1. It's going to remainder 1. So that's going to be 1. That's 1. We are going to now say 16 divided by 15, but we are still going to carry it with the 15. Then that's going to be, this is now going to be 1 remainder 1 all over 15. Now, The 1, remember 1, all over 15. Now, the 1 here is what? Is now going to be one whole number. That's going to stand as whole number. Then 1 all over 15. Mind you, is this our final answer? No. This is not our final answer. Remember what we did. The 7, the calculation we got here, in the previous one, up at the top, we said for the whole number, we said 7 minus, can you tell me? Minus 2, correct. And which gave us 5. So we are going to go back to that now. And that 5, we are going to bring it down to this. We are going to add it together. So bringing the 5 whole number that we've calculated before in the previous one, you can just scroll up to check. So 5, the 5 now, you are going to join it together with this. Don't forget we have one whole number, 1 all over 5, all over 15. Yeah, which is this result. Now, the 5 whole number, we are adding it to this now because, why are we adding it to this? We are adding it to this because this one also has a whole number here. Based on what we have done here, based on the 1, remainder 1. So, 1, we are going to add this one whole number to this 5. Let's do that. 5 plus 1 gives us what? Add them together. That's going to be 6. That's 6 whole number, 1 all over 15. So, this is your final answer. This is the final answer. So, you are then going to go, you have to go back to your options and see where your answer lies. Then shade your answer. So, you can go back to the question once again to solve the questions. So, just do one thing for me. Go through the question, put it in your paper, solve it again like I have explained, then see if you get the result. If you do not get the result, don't give up. Go back again, do it again, follow my samples, and do it one more time. You can do it. Yes, this is now question 7. We have this, which is write in figures 1,580,250. 1,580,250. This should not be difficult for you because I know you are smart. Now, what will you do? Look at this. Different technique. You can just look at the figure, read it. After reading it, check your option and pick the right answer because I know you can do this. Now, but despite you can do this, I'm still going to explain it. Look at this solution. To get this right, for you not to fail it, don't forget, simple questions can lead to simple failure. Now, so look at this now. 1 million, let's break it down first, based on million, based on thousand, after million, which is thousand, and the smaller unit, which is the hundred, the tens, and the units. Now, I want to break them down now. 1 million, this is my first breaking, 1 million. Can you write in 1 million? If you can do that, then let's see. How many figures of 0 do you have in million? Okay, and that is 6 zeros, which means you have 1, then 6 zeros at the front. That's going to be 1, 1, 2, 3, 1, 2, 3. Now, so that is 1 million. Space, space, or you put comma. So, now the next one, which is 1,000. You have 580,000, which is 580,000. How do you write your 580? How do you do that? Okay, now this is 580. So, but here in this case, it is under 1,000. It's going to be under 1,000, which means 580 of 1,000. Now, I'm going to write both of them together now. 580,000. 580,000, and that's going to be 580,000 now will be 580, then 3 zeros, which stands for 1,000, which means 580,000. Now I'm going to place them here. Where will be my 580? 1, 2, 3. It's going to be here. 580, then 0, 0, and 0. Now, lastly, the last smaller unit, which is 250. 200. 250. Now, and that's going to be 250. Don't forget, 250, which is written as this, 250, they are just 3-digit figure. Now you come down to this 1, 2, 3, and that's going to be 250. Now, so the next thing you have just done, this is what we have just done. We have just broken all the figure word form of this number down to figure form. Word form, figure form. These ones are word form, while these ones are figure form. Now the next thing you have to do, add them together. Now you have to add them together, and that's going to be 0, 5, 2, 0, 8, 5, and 1. Eventually you have the figure form finally, which is 1,580,250, and that's the figure one form. And that's the figure form. You can go back to it again and try the question again, then see what your result will be. The question says, how many prime numbers are there between 1 and 20? How many prime numbers are there between 1 and 20? What are we saying here? Prime numbers. Like I said before, I said prime numbers are numbers. Prime numbers are numbers that have 2 factors. And the 2 factors are 1, which means 1 and the number itself. Which means that what? These 2 numbers can divide these numbers without any remainder. Now, here now, the question says, how many prime numbers are there between 1 and 20? Between 1 and 20. What will you do? What you are going to do here is that first, you are going to list out 1 to 20 for you not to make mistake, for you not to miss out on anyone. List out 1 to 20. Let's start. 1. Now, I have the list of my numbers. Now, after you have listed them out, the next thing you have to do is identify the numbers that are prime, that can be divided by 1 and only themselves. 1 and themselves only. Now, let's check. Is 1 a prime number? No. Why? Because 1 has just 1 factor. For example, prime factors of 1 is 1, just 1 factor. Now, is 2 a prime number? Yes. 1 and 2 can divide 2 without any remainder. You can see what I said, 1 and the number itself, which means 1 can divide 2 without any remainder. 2 also can divide 2 without any remainder. This is what we meant by this is prime number. So 2 is a prime number. I'm going to take this off. I've taken that off by cancelling it. Now, 3. Let's check 3. 1 can divide 3, yes, without any remainder. 2 can divide 3, but it will remainder 1. So 2 is not a prime, is not a factor of 3. Now 3, yes, which means 1 and 3. So 3, do you know? Okay, 3 is also a prime number. So I'm going to cancel 3. Now 4. Check your 4. 4, now you have 1 can go in 4, 2 can go in 4, 4 can go in 4. Look at this. This one has more than 2 factors. So is 4 a prime number? No, 4 is not a prime number. So we are not going to take away 4 there. Now, what of 5? 1 can divide 5 without any remainder, yes. 2 can divide 5, but it will remainder 1. So 2 is not a factor of 5. 3 can divide 5, but it will remainder 2. 3 is not a factor of this 5. Likewise, 4 can divide 5, but it will remainder 1. 4 is not a factor of 5. Then the next factor is 5. 5, which is 1 and 5, can divide 5 without any remainder. So which means 5 is a prime number. Now, the next one, 6. 6 is not a prime, like what we have just done. Keep doing that on your own now. You will see what, you've seen what I've done, similar things I've done here. So you can also try it on your own, then you'll see. Now, 6 is not a prime number, so we will not take off 6 from there. 7 is a prime number, yes. 8 is not a prime number, yes, because it has more than 2 factors. Likewise, 9 is not a prime number, it has more than 2 factors. 10 is not also a prime number because it has more than 2 factors. 11 is a prime number because it has 2 factors. 12 is not a prime number because it has more than 2 factors. 13 is a prime number because it has 2 factors, so it's a prime number. 14 is not a prime number because it has more than 2 factors. 15 is not a prime number because it has more than 2 factors. 16 is not a prime number because it has more than 2 factors. 17 is a prime number because it is 1 and 17. Now, 18 is not a prime number because it has more than 2 factors. 19 is a prime number because the factors are 1 and 19. 20 is not a prime number because it has more than 2 factors. Now, what are the prime numbers? The prime numbers now, let's write them out. Can you follow me? Those ones cancelled. 2, correct. 3, 5, 7, 11, 13, 17, and 19. These are the prime numbers between 1 to 20. These are the prime numbers. Now, the question now, let's go back to the question. They said, how many? You should take note of that question. They said, how many? The question says, how many? So, after you have written all the prime numbers, then you need to count the number of prime numbers that we have there. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. Which means we have 8 prime numbers between 1 to 20. 8 prime numbers between 1 to 20. Your final answer now will be, there are 8 prime numbers. There are 8 prime numbers between 1 and 20. So that is your answer, which means 8. You have to then look for 8 as your answer. Final answer, which is 8, 8. 8 prime numbers. So that's that. Yes. Question number 9. It says, write in Roman numerals 839, which means 839. Write in Roman numerals. You will discover that they said Roman numerals, which means it's not just an ordinary number you are familiar with. So, you are also familiar with the Roman style of writing, which means the use of letters. Now, how can we then change this to Roman numeral? First, what to do? What you have to do first, apply your technique of place value. The place value of the numbers. Split them. Also apply what we call expansionary technique, which means place value. This is unit, tens, 100. Now, which means 8 is 100, 3, which is tens, which is the same thing as saying 30, while 9 remain 9. Then you apply the expansion. You expand them by saying 800 plus 30 plus 9. So, after that, you can then turn them to your Roman numeral. So, let's see. Now, which means 830, I want to expand them now. That's going to be unit, tens, and hundred. Which is now, this is going to be 800 plus 30 plus 9. Then after which, after I've expanded this, after you have done that, now the next thing is to observe the 800. Turn them now to Roman numeral. To Roman numeral now, 800 in Roman numeral. Do you remember that 800 is closer to 500 in Roman? Yes. And that will be 500 plus what? We give you 800 plus 300, correct? Plus 300. Now, 500 plus 300, if you check this now, what is the Roman numeral letter of 500? Roman numeral letter of 500. Roman numeral letter of 500 is D, correct. Now, Y of 300 is what? Which means 3 letters, CC, C, which is 3 letters, DCCC. Putting them together, you have DCCC, which stands for 800. Now, coming down, we have DCCC, which is for 800 plus, then this one also 30. Your 30 is counting in tens, and that is 10 plus 10 plus 10 will give you 30. And that's going to be Roman numerals of 10 is x, which is x, x, x. 3x will give you 30 in Roman numeral. Plus, then drop your 9. Your 9 Roman numeral is what? Don't forget, 10 is more than 9 and 10 is x. So, if you want to get your 9, you have to remove 1 from 10, and that will be 10 minus 1, which is 9. So, likewise, don't forget, your 1 in Roman numeral is I, which is I, letter I. So, I must come before x, which means to give you 9. Ix is 9. That's to tell you Ix is 9. So, bringing them together now, your final answer now, adding them together, that will be DCCC, XXX, IX. This is your final answer. That is your final answer. So, which means 839 is equal to DCCC XXX IX in Roman numeral. It's just a simple technique. You can just pause the stuff and go through the question once again and solve the question on your own. Evaluate square root of 36 all over 144. This symbol stands for square root. So whenever you see the symbol, it is referred to as square root. So square root means a particular number that will times itself twice to give you the number inside the symbol. For example, 4. Look at this number inside the symbol is 4. Can you think of a number that will times itself, a particular number that will times itself twice in your multiplication table that will give you 4? Correct, and that is 2. 2 is the number. So which means 2 times 2 will give you 4. So 2 is that number that will times itself twice to give you 4. So whenever you see this kind of question in your mathematics, you should note that you have to look for you have to check for a particular number that can times itself twice to give you the number inside the symbol, and that is 2. Now, coming back to this question now, you are going to see, you are looking at this question which has fraction inside the symbol of the square root, which means that you have to find the square root of 36, find the square root of 144, and that's going to be this solution. Square root of 36 all over 144. And that's going to be, split it, let's separate them. That's going to be square root of 36 all over square root of 144. Now, what then is the square root of 36? Can you guess? Good guessing. Now, let's see, which means 6 is the number. 6 times 6 will give you 36 all over. What about 144? 9 is 1. That's going to be 12 times 12, which gives you 144. Now, you bracket them. Then, can you now tell me what is that number that times itself twice to give you 36? Great, it is 6 all over. So you put only 6 there. What is the number that times itself twice to give us 144? Correct, it is 12. So you have 6 all over 12. Is this, the question now is this our final answer? No, this is not our final answer. Why? Because in this fraction, you have what? Something can go in both, which means there's something in common, which is we are going to apply the common factors. So something can divide both number up and down to give us our lowest 10. Now, so we are going then to divide 6 by a part. Can you tell me now what is that number that can go here and here? Good of you, which is 3. Or you can also say 2. So I'm using 3 now. So likewise, 3 can also go in 12. And that would be what? 3 here is what? 2. 3 here is 4. Great. That's going to be 2 all over 4. Now, check again. There's another number that can go again. Again, in these 2 and 4, you can still use that same number again, and that's going to be 2. 2 divided by 2 all over 4 divided by 2. And that's going to give us what? That's going to be 2 here, 1, 2 here, which is 2, which is 1 all over 2. Do we have any other number that can go in 1 all over 2? Common number? No. If you say 1, yes, 1, it will still give you 1 all over 2. So we are going to stop here. This is the lowest 10. That is your final answer. So the final answer for this kind of question, which says evaluate this square root of 36 all over 144 is 1 is equals to 1 all over 2 as the final answer. That is your final answer. So you can go back to the question one more time, solve it one more time, then check what you have as your answer.